China's mighty Y-20 cargo plane. Reshaping the global air transport landscape. What makes the Y-20 so remarkable? In the eyes of the world's air transport community? Hey, did you know that soaring through the skies is a kunpeng from the east? Every flap of its wings is turning heads worldwide. This kunpeng is China's Y-20 large transport aircraft. You might have caught a glimpse of its massive and agile form in the news, but do you really know the story behind it? How did it go from a mere concept to a steel behemoth soaring through the heavens? And why has it managed to carve out its own niche in the fiercely competitive global transport aircraft arena, even reshaping the global air transport landscape? Today, let's uncover some of the lesser-known inside stories of the Y-20. The birth of the Y-20 is the magnificent result of the nation's foresight and meticulous planning, carrying the weight of national will. In 2006, facing a complex international situation and the urgent needs of national development, the country swiftly organized the major science and technology special project demonstration for large aircraft. A group of top industry experts gathered, and after multiple rounds of rigorous discussions and analyses, they unanimously agreed that large aircraft play a crucial role in enhancing the overall national strength and are a strategic focus for strengthening China's independent innovation capabilities. This conclusion shone like a beacon in the fog, pointing the way forward for the future development of China's aviation industry. In 2007, the State Council's executive meeting officially approved the establishment of the Major Science and Technology Special Project for Large Aircraft Development. This decision was like a boulder thrown into a calm lake, creating huge waves in the aviation field and declaring China's firm determination to take on the challenge of developing large aircraft. Subsequently, the military equipment authorities quickly worked with the Commission of Science, Technology and Industry for National Defense to convene a mobilization and deployment meeting for the development of large transport aircraft, clearly designating the first aircraft institute to be responsible for the design and Xi'an Aircraft Industry Corporation, XISI, to undertake the main manufacturing tasks. This series of intense operations was like a finely choreographed drama. From project demonstration to approval, and then to the determination of design and manufacturing units, each step was closely linked and crucial, all aimed at achieving one goal: to facilitate the smooth birth of the Y-20 and usher in a new chapter in China's aviation industry. From design to manufacturing, every aspect of the Y-20 was fraught with challenges. The wing design adopted a supercritical airfoil, which was no easy feat. The design team had to complete the plan on time and ensure that its aerodynamic performance met the design requirements. Do you know how difficult that is? It's like walking a tightrope in the high sky. A slight misstep could lead to complete failure. But the team did it, successfully applying this technology to improve the aircraft's performance. During the structural drawing phase, the first Aircraft Institute completed a large number of drawing releases, digital model establishment, and experiments. Every piece of data and every drawing embodied the painstaking efforts of countless researchers. The design of the Flight Management System, FMS, posed a huge challenge. The first Aircraft Institute and related institutions formed a joint research team and spent 3 years overcoming technical difficulties. The all-time, full-authority fly-by-wire flight control system technology was even more critical. The first Aircraft Institute and AVIC Flight Automatic Control Research Institute, among others, repeatedly conducted research and experiments, and finally successfully developed the fly-by-wire flight control system. These achievements were not obtained casually. Behind them were countless days and nights of hard work and dedication. In the manufacturing stage, the Y-20 also faced many problems. The design emphasized structural weight reduction, and the chief designer systematically adopted various methods to reduce the structural weight. The prototype production was extremely complex, and XAC faced enormous pressure in final assembly and integration. Shaanxi Aircraft Industry Group independently funded the construction of a digital work platform, and the landing gear company significantly improved the technical level of the multi-wheel, multi-strut landing gear it prototyped. The entire prototype production process achieved a seamless integration of digital design and manufacturing, overcoming hundreds of key manufacturing technologies. In September 2010, the Aeronautical Manufacturing Technology Institute solved the manufacturing problem of the aircraft's main flaptrack in just 3 months. XISI collaborated with universities to achieve a one-time successful large cross-docking of the Y-20, promoting the advancement of large aircraft assembly towards automation, digitalization, and flexible assembly. These breakthroughs laid a solid foundation for the birth of the Y-20. Finally, on January 26, 2013, China's domestically produced large, multi-purpose transport aircraft, the Y-20, successfully completed its maiden flight. This flight was a momentous occasion, marking a significant breakthrough for China in the field of large transport aircraft. In July 2016, the Y-20 was commissioned into the military, officially beginning its mission journey. Subsequently, the Y-20B, equipped with 4 domestically produced high-thrust, high-bypass turbofan WS-20 engines, completed its test flight and was equipped by the troops, further enhancing the Y-20's capabilities. Now, let's take a detailed look at the Y-20's performance, which is truly remarkable. It adopts a high-wing configuration, wing-mounted engines, and a T-tail aerodynamic layout, equipped with 4 turbofan engines and 1 auxiliary power unit. The fuselage is wide-bodied with a flattened circular cross-section, featuring a fully pressurized cargo cabin and a large rear cargo door, along with a multi-wheel, multi-strut tricycle landing gear. The semi-monocoque fuselage consists of frames, longerons/beams, and skin. The cockpit and cargo cabin can be isolated and pressurized. The wing is a swept trapezoidal supercritical wing, with the wing box serving as an integral fuel tank, equipped with full-span slats and triple-slotted Fowler flaps. The main structure of the T-shaped high horizontal tail is made of carbon fiber composite materials, while the vertical stabilizer has a 2-spar structure, with the rudder divided into 2 parts, each with forward and aft linked sections. The all-moving horizontal tail can be adjusted in pitch, and the elevators are divided into inner and outer segments. The landing gear includes nose, main, and tail support units. The nose landing gear has conventional tandem dual wheels, while the main landing gear is a multi-wheel, multi-strut, oblique-braced, shock-absorbing type, with 3 struts and 6 wheels on each side of the fuselage. The landing gear is also equipped with temperature and pressure monitoring devices. This series of designs allows the Y-20 to achieve a very high level of performance. The aircraft employs a 2-pilot glass cockpit and fly-by-wire controls, featuring various control surfaces to ensure flight quality and the ability to fly safely under special circumstances. The forward fuselage has symmetrical boarding/paratrooper doors, and the rear cargo compartment has a 5-door configuration. The cargo compartment is equipped with loading/unloading and airdrop devices. The flight control system is comprehensive, with 3 sets of hydraulic power ensuring control, and the environmental control system can automatically control and monitor. The integrated avionics system is centered around 2 integrated processors and uses an AFDX network as the main bus. The cockpit utilizes integrated display and control technology, employing specific equipment for human-machine interaction. This makes the Y-20's operation more convenient and efficient, and also improves flight safety. The Y-20 has cargo and personnel transportation, airdrop, and mission management capabilities. It is designed to be versatile and modular, with rapid configuration conversion, capable of meeting various transportation needs and possessing multiple airdrop and paratroop capabilities. The mission management system can complete various mission-related operations. The aircraft utilizes distributed technology to achieve multi-system control and information management, with functions such as fault detection and status monitoring. In terms of performance data, the crew consists of 3 people. The aircraft has a length of 47 meters, a wingspan of 50 meters, a height of 15 meters, and a wing area of 330 square meters. The maximum takeoff weight is 179,000 kilograms, the maximum fuel capacity is 77,500 kilograms, and the maximum payload is 55,000 kilograms, based on data with D30KP2 engines. Engine options include the D30KP2, maximum thrust of 103 knots per engine, or the WS-20, among others. The maximum speed is 750 to 920 km per hour, the service ceiling is 13,000 meters, the range is greater than 7,800 km, the range with a full payload is 4,400 km, and the takeoff and landing runway distance is 800 meters. Such performance places it in an important position among large transport aircraft globally. Compared with the transport aircraft of European and American countries, the Y-20 also has its own advantages and characteristics. Take the American C-17 transport aircraft as an example. The C-17 has a fuselage length of 53 meters, a height of 16.79 meters, and a wingspan of 51.8 meters, making it slightly larger than the Y-20 in terms of dimensions. The internal cargo compartment of the C-17 has a length of 26.83 meters, a width of 5.49 meters, and a minimum height of 3.76 meters. In terms of carrying capacity, the C-17's normal maximum takeoff weight is said to be 265 tons, and the officially announced maximum payload is 77.5 tons. When the early Y-20 used D-30 KP2 engines in China's domestically produced WS-18 engines, there was a significant gap in maximum takeoff weight and payload compared to the C-17. However, with the advent of the Y-20B, which uses WS-20 engines, the maximum takeoff weight may increase by 10 to 20 tons, and the maximum payload may reach up to 66 tons, or at least over 60 tons, constantly narrowing the gap with the C-17. Moreover, the Y-20 has unique features in some aspects. For example, its avionics and flight control systems have been continuously optimized, possessing a high degree of automation, which can reduce the pilot's workload and enable functions such as low-altitude night flight. This is of great significance in combat and special mission execution. Looking at Europe's A400M transport aircraft, its tonnage is smaller and it cannot transport main battle tanks, placing it in a different class than the Y-20. The Y-20's cargo floor width exceeds 4.5 meters, allowing it to easily accommodate not only main battle tanks but also larger missile launch vehicles, giving it a clear advantage in transporting large military equipment. Furthermore, the Y-20 has a long range, a maximum takeoff weight of 220 tons, and a conservatively estimated fuel capacity of over 60 tons. Utilizing a supercritical wing and drag-reducing design, its excellent aerodynamic shape allows it to fly nearly 10,000 kilometers. This range advantage is crucial for global power projection. From a global perspective, large transport aircraft are of great strategic significance to a nation. In the Iraq War, the United States used transport aircraft to deliver more than 95% of the total invested military equipment, weapons, and ammunition. This means that over 95% of all the forces the U.S. deployed to the battlefield were transported using cargo planes. The efficiency of transport aircraft is faster, more accurate, more efficient, and has a higher safety factor compared to other means. Similarly, comparing it to sea transportation of troops, transport aircraft can deliver all military equipment to the battlefield in just a few hours, while sea voyages can take more than 10 or even dozens of hours to arrive. In emergencies when rapid deployment of troops and combat power is needed, the role of transport aircraft is self-evident. The emergence of the Y-20 has greatly enhanced China's strategic airlift capability, giving China a stronger voice in its global strategic layout. The Y-20 not only plays a crucial role in the military field but also has enormous potential in civilian and humanitarian aid efforts. During the severe epidemic, the Y-20 transported hundreds of tons of supplies and thousands of medical personnel to Wuhan, making a significant contribution to the fight against the pandemic. It has also repeatedly represented the country in providing friendly assistance and humanitarian aid to other nations, demonstrating China's responsibility as a major power. Moreover, the civilian version of the Y-20, the Y-20 F-100, made its debut at the Zhuhai Airshow in 2024. Its cargo hold design has been optimized to support the installation of standardized civilian containers and pallets, and it is expected to fill gaps and play an important role in international cargo transportation and the domestic ultra-large cargo aircraft sector in the future. Looking ahead, the Y-20 will continue to develop and improve. With continuous technological advancements, the Y-20 may see further enhancements in payload capacity, range, and avionics systems. At the same time, China may also develop larger and more advanced transport aircraft to meet the country's growing strategic needs. The success of the Y-20 has accumulated valuable experience for the development of China's aviation industry and laid a solid foundation for the research and development of subsequent models. It shines like a bright star, illuminating the path forward for China's aviation industry. The story of the Y-20 is a legend full of hard work and struggle. It has witnessed China's rise in the field of science and technology and demonstrated the wisdom and courage of the Chinese people. We hope everyone will continue to pay attention to the development of the Y-20 and the continuous progress of China's aviation industry. We believe that in the future, China's aviation endeavors will bring China even more surprises. Thank you for reading, and see you in the next issue.